Hey, thank you very much. I appreciate the opportunity to participate in this event. Thank you very much. Starting off, I'm sorry. The Metropolitan Mosquito Control District is located in Minnesota, up in the upper Midwest, and our district services the Minneapolis-St. Paul area. We cover about 3,000 square miles in 7 counties and service a population of about 3 million people. Our annual budget is about $9 million, and we have 7 facilities in which we service our area. We have about 54 full-time staff and 210 people, seasonal inspectors in that. We contract out with 6 Jet Ranger helicopters that are for exclusive use for our program, and we focus on larval mosquito control. The MMCD has a long history of with Methoprene. Our former director in the 1980s, Dr. Robert Trogan, worked closely with the Zoicon Corporation to develop a lot of the formulations, the Alticid formulations that are around today. And many of the use patterns and product evaluation techniques used today were created as MMCD became an early adopter of that those products. What we have here is a map of our 7-county metropolitan area. It is, you can see Minneapolis would be here and St. Paul there. You know, Minnesota is known as the land of 10,000 lakes. I think it should also include, we're also the land of 100,000 wetlands. So we have a lot of them in our district. You know, we have identified about 81,000 different breeding sites, which, you know, can be seen in red. And that habitat is included in, you know, both urban in the core of our cities, and then working out to suburban, and in the far reaches of our district, we have more rural areas. We do not have the resources to treat all these sites, so a big part of our job is to prioritize which ones will have the most impact on our citizens, you know, how we can control and do the best for the common good. And we try to utilize all active ingredients to operate in the most efficient, environmentally sensitive, and cost-efficient means possible. When we look at our operational strategies, we focus our control on areas of high population and surrounding areas in which would affect those areas. All our treatments are done according to thresholds and larval surveillance and site history. Our entomology lab will probably look at somewhere in the ballpark of 20,000 samples per year. And we utilize a database system, a GIS database system, which is our inspectors can directly access and input data and have real-time information using their smartphones. We utilize site histories quite a bit in this when we look at what sites to use pre-hatch or residual materials compared to like a shorter term BTI problem. And what we look at is if a site will produce mosquitoes like 3 times in a 30-day period, that would be a good candidate for using residual control. The majority of our sites are treated by helicopter. We usually target sites that are greater than 2 acres, with anything less than that being treated by ground. We're really all in on larviciding, since that about 93% of our control budget does go towards larvicides. And we usually target for evaluating control in our treatments as approximately about 10% of our sites. That may seem like a low number, but when you're looking at the thousands of sites that we treat on an annual basis, it does get to be significant. So one of the things that we focus on is, since we do all of our work with helicopters, is really doing a good job with that application platform. You know, it is really critical for these low rate applications, talking in the ballpark of 3, 4, 5 pounds an acre, that you do a really good job. And I mean, all of us know that if you get the product where the mosquitoes are at the right dosage, you'll have real good control. So that's really our target. One of the things that we did is we developed a mobile calibration system in which we purchased a 24-foot trailer and made a mobile lab, customized it for that. It's all self-contained. With the use of generator, we can go anywhere in our metropolitan area that we have a field large enough to set up and do calibrations or helicopter checks at that time. So what we end up doing is putting out a series of trampolines. You can see on the bottom of these collectors, the helicopter will fly over. In the lower left-hand corner, you can see each of these trampolines has a vial on it. We can collect the materials that fall out of in our swath patterns. We can bring them back into our trailer, measure the weight of that, and then eventually enter that into a statistical program in which we can identify our swath patterns. One thing that is important to know, you know, each of these materials, no matter if you're looking at metal R, pellets, natural R, BTI, they all have their own unique characteristics, and you know, each has its own bulk density, you know, or aerodynamic qualities that you have to adjust for and look at. And when you're looking at these really low rates, those features really do come out, and it will show you many different patterns, and it's important that you understand the capabilities of each material and also know its limitations on how you can best utilize that and set that up for application. It's also important to note that each aircraft has, you know, a unique application pattern that, you know, when you're looking at, you know, a lot of the rotary craft that we use, you have two hoppers on the side of your helicopter, and you need to be able to understand how both those units work in unison to produce your swath. Sometimes it's difficult to know what materials coming from which side, you know, so a lot of what we've started to look at is using colored blanks in one side of that hopper, and that helps us understand exactly what's occurring in our swath pattern and how each hopper itself contributes to that different pattern. One thing also is to note that helicopter shape, you know, the fuselage shape or the amount of rotors that you have, you know, whether it's 2-blade, 4-blade, 5-blade, and the different helicopters you have, that also can produce different patterns, and you might need to look at that fuselage shape or that rotor wash and that in helping you determine how to produce the best pattern for your larvicide operations. So once you get all this figured out, there's a point where you get to the operational side that you need to be able to get an operational swath distance. When a helicopter is putting out materials, you may end up putting out a 100-foot swath or a 90-foot swath, whatever, with that. But to be able to put out materials at a consistent rate, especially at these low rates, you need to make that cutoff where you know, in the upper right corner here, if you look at, you may need to cut off some of those outliers in there and cut off to a certain distance in which will perform your swath in a consistent manner across all your sites. What we use is a statistical program to help us decide that. We use a program designed by a company called WRK, which was developed for the agricultural industry. They have a granular deposition software that helps determine what is the best swath for the material, and that you can look at the different swath distances, and it helps you calculate out the rates and some statistics in which can help you decide what is the best swath width for that particular material. For us, typically, we had come out with an operational swath of about 80 feet for sand type granule, and then 72 feet for some of the lighter corncob materials. And that way you're able to, if you look in the lower right corner here, you can look at the projections from our AgNav tracking system, our flight paths, in which you can project that 80-foot swath on those, and you can help understand your treatments and look at and ensure that you have good coverage on all your treatments in that standpoint. You know, so how did we determine our application rates? You know, going back with that work from Dr. Sjogren and that, we did a lot of development work looking at what would be the best rate, you know, for floodwater control, and through trial and error, you know, we actually found that about 2.85 pounds per acre of Alticid pellets achieved about 90% emergence inhibition. You know, we used to have a program in there, about 8 people in our district here that just solely worked on efficacy and applications, and worked at a way to continually improve those. So we have a lot of extensive experience in evaluating, you know, these products and that. And what we kind of use is that pellet, that 90% EI, as kind of the standard in which we judge other programs or other formulations and products in the market, and that as we look at it, evaluating those. Operationally, we still see Methoprene falling in, you know, the range between 75 and 95 emergence inhibition. You know, I always say that, you know, there's a lot of things that we understand about Methoprene, but there's a lot of things that we don't. You know, we have, you know, from personal experience in that, I've looked at a lot of different sites where, you know, you might have sites side by side, treat them both equally, same time of day, same, you know, environmental conditions, and you'll get different control rates in there, and that you know, things that you can't necessarily explain. That happens sometime, but in the majority, you know, we get really good quality control from those products. How do we test? You know, we do a lot of laboratory and field bioassays, in which our inspectors would go out into the site. They would collect pupa, bring them back to the lab, and then hatch them out and be able to get percentage hatch from that. Of course, we use control sites and that to determine the natural mortality, and that is corrected in our testing results for the product. So we do a lot of that. And one thing to remember is that some things that might affect some of the rates in your bioassays is that when you are collecting pupa, you are removing them from the site and that source of Methoprene. So when they're in the laboratory, they might not be receiving the same amount of Methoprene as in the field, and that may have a small contribution to your efficacy results. But, you know, for the most part, we've had really good success using that method to evaluate our products. And we do use some emergence trapping, especially in some of our Clocotidia perturbans sites, where we can actually set up emergence traps, as you can see in the lower right corner. These traps are set up over the vegetation and collect the insects as they hatch off. And there, I think we get a much truer reading of the product, because those insects, those mosquitoes, stay in that water with that Methoprene source all the way up to that moment of hatching. So I think that's a good, solid evaluation method. And, you know, with our applications rates, economics always plays a part in our decisions. You know, we're trying to cover such a large area and maximize that coverage. So that does play a part in how we evaluate. So that gets a little bit in, with pre-hatch control, just kind of go into a little bit of the, philosophy is, when we look at control with pre-hatch products, and that is just, you have to kind of make a decision on how much control is enough. Are you targeting 100%, 90%, 80%? I think if you're in a smaller district, you certainly would want to try to get close to, 100% efficacy that you can. Sometimes when we're treating larger areas, there might be some trade-off to maybe get 85% control in more sites as opposed to getting 100% control in fewer sites when you're covering such a large geographical area. One of the things that we like to look at is that when we look at all the tools in our toolbox and all the different control materials that we have, how can we have them work together to maximize our effectiveness? And we look at, I talked earlier about, looking at our sites that produce mosquitoes, 3 times in a 30-day period, that might be a way to maximize that effectiveness of your program. Other days when we're covering large areas, we might want to look at maybe, concentrating pre-hatch areas in certain hard to reach areas. And then when we do have the rains and floodwaters, we can concentrate and be more efficient in control with a product, let's say like BTI, in other areas. We're always trying to get better at what we do and get more efficient. So that is always a quality improvement is always a goal of ours. I think it's important. I know it's been spoken to on by a few of the other speakers that we need to take care of our AIs. We do have active ingredients. We do have a limited number of active ingredients, so it's important that you try to protect that use and avoid any sort of resistance, especially when you're looking at low rates. So I think you need a good management plan that includes product rotation in there to help keep these materials working at their peak efficiency. Some of the other things that we look at is duration of the products and that time frame. Do you have that residual control? When do you use it? We always look at it as a risk versus reward. Is the site going to be wet for that full 30-day period? Let's say later in the summer, that we may not risk putting in 30 days product if we're not going to possibly receive the 30 days of control. So we end up doing a lot of our control with the pre-hatch products earlier in the spring when we know those sites will maintain that wetness, or receive those repeated rains and that product will be fully reutilized in the spring. So some things to think about. For us, we have 2 main pest species. We have the 80s floodwater species that are, one of our main pest areas, but we also have Clocotidia perturbans, which is another main pest species that come off. But in our area, the perturbans give us an advantage because they overwinter as larvae. We're able to survey those in the fall period and know what's going to most likely happen in the next spring. So, we look at weighing, we see that as a known, and we do some maybe heavily weight our pre-hatch program towards more of those perturban sites versus 80s floodwaters where, some of that thing, if we have a dry year, holding back some of those control materials to use in those times, might be, a gamble. So, it's a really balancing act, and it's just some things to think about. Another area where we use a lot of pre-hatch is in limited access sites. We have areas like, let's say, around our international airport where they don't want helicopters flying in there quite a bit. We use them there. Areas of high-use parks where you have a lot of public interaction, or maybe horse farms, or around schools where you don't want that aircraft in, possibly creating some public relation issues, and that I don't think anybody likes to deal with those. So, and lastly, for us, we're all about efficiency and trying to get to as many sites as we possibly can in a given period of time. So, you know, using these low rate materials, and that allows us to get more flight time with our helicopters. When our helicopters are flying, we want them to be applying materials, you know, so they're able to take with these low rate pre-hatch materials, they're able to take more material and fly more acres, and not be returning back to ferry and gain more materials all the time. So we like that because we like to fly as many acres per day as that we can when we have good conditions to fly. Lastly, what I'm going to touch on is drone applications. I know some of the other people have used those. I think these low applications rates are ideal for their payload and flight time. We have done some work and had great success, and we are still determining what, you know, how best to utilize or find that niche for that technology. Lastly, I'd like to say is that the Metropolitan Mosquito Control District does have what I think are some high quality reports and technical reviews that we do every year. Those may be a resource for you if you want to look at some of the work that we've done. And those are available on our website at mmcd.org. So with that, I am finished, and I thank you for your time today.